Hello everyone. In this video, I will demonstrate how to create views and how to perform operations like insertion, deletion, and updation to the base tables using views. So views are simply, customized picture of the same data that you create for different users. So why would you like to create views? Because at times you want to hide sensitive information like bank account information or social security number or driver's license that you do not want to share with the user of the view, so you can comfortably hide it. Secondly, you can create multiple views or multiple pictures of the same data depending on the need uh, that you have for different users of the views. So you can sort of create customized picture of the same data set. So now what you need to keep in mind is, views are known as derived tables. They are different than the base tables. Base tables are the permanent tables in the database. Like we have here customers, item, order line, orders, and rep. These are our base tables, and these are permanently stored in our database. On the other hand, views are not the permanent table. They are derived table because they are derived using one or more base tables. That's something you have to keep in mind. So with that little information, let's get started. Let's say you want to create the first view. Create a view named toys that consists of the item number, description, units on hand, unit price of each item in the category toy. So let's first write the query that will fetch this details. So we'll say here, select from item where category equals toy. Okay, and what we want to select here, we want to, if you expand item table, I want to select item underscore number, and I want to select description and on hand, and I want to select price. Okay, from toys. So let's run this one. So the best way to run the command that I like is press the control key and enter key. So I'm going to use my local user as a connection here, and this will give me this records. Now this is just a snapshot or of the data where we are saying that, okay, I want to fetch only this information. Let's say I want to give this query a name. Okay, and that's what a view does. So we will store a query in our database that you can run again and again to get the latest information from the base table. So here we will say create or replace view toys as. Okay, this is the syntax. So it will create the views. If the view already exists, it will replace that view, and you just say as here and provide your query. So this is basically going to create a view. So if I hit control enter here, a view toys created, and you can see it here as well. If you go to the views, you will see that a toys view is created. Now this toy view could be seen as just a table for the user of the view. For example, what we can do is we can say select star from. Now we're gonna provide the name of the view here, so toys. So SQL select star from toys. Okay, so this will fetch the data from the toys. So for the users of toys, this simply appears as a table, but this is not a table. Basically it's a query. Okay, that's something to keep in mind. Moving on, let's say you want to select the item number description using our view here where the price is greater than 100. Okay, so what I can do here is can write the query here. Select, say let's say we have select from toys, okay, where let's say price is greater than 100, and I want to select item number description. Okay, so you, as you can see here, okay, I need to end the command here. Okay, okay, so let's see invalid identifier is greater than 100. Okay, description may be spelled not right. Let's see, DESCRIPTION. So we have to be careful with the spelling mistakes here. Okay, so you can use that toy simply as a derived table and perform other search operations on the table. Behind the scene, what it is doing is, it's just adding this additional search criteria to your existing view here. Okay, so basically behind the scene, if you want to write the query, this is how it will look like. Okay, so, and I'm just gonna add this additional piece here and say, and okay, so this will do the same thing. Okay, so you can see basically when you put a search criteria on the views, then basically behind the scene it's adding that search criteria to the existing query that you used to create the view. That's something you have to keep in mind here. Okay, so moving on, this is here we just created a view based on um, one table called item. Okay, and point to note here is that we have used item number, which is a primary key in our view. Okay, so that will provide us a reference when it comes to update the data using view in our item table. Okay, something you have to keep in mind, and we'll get back to it. uh, let's create another view here. Create a view named called TYS that consists of item number, description, units on hand, and unit price of all item in the category toy. So basically it's the same view. We want to create another view based on the same data like what we have here, but this time what we want to do is we want to give a different name. We don't want to use the name used in the item table. So fairly simple here. So I will just copy this one because I'll be using the same view here. So here we want to create a view called TYS. Okay, and we want to give a name, so the name should match with the sequence. So we want to call item as the item number here, and then we want to call DSC for the description, and then OH is on hand, and then price for the price. Okay, S. So you see that, where there has to be one-to-one correspondence here. Item number, description, or on hand, price, and price. Otherwise it will not make sense when you going to retrieve the data from the view. Okay, so this is it. If you create this one, the view is created, and you can use that view as we have used before. So select star from TYS. Okay, control enter, and it will give you the data here, the same data that you got before, but here you see that you have used different names for the fields, okay, other than what you have in the base table called item. So moving on, view based on join. So as I said before, you can write a query that joins multiple tables. Okay, so a view could involve join as well. Let's create this one. Let's say you want to create a view called rep underscore cust, consist of the sales rep number, sales rep last name, first name, customer number, and customer name. Okay, and you want to give the different names to it. So let's do first, as we always do, first write the query. So I will say here, select from, say, rep, or I'm going to use inner join customer C on, let's say, r dot rep underscore number equals C dot rep underscore number. Okay, so that's the join I'm going to use. And what I want to select here is r dot rep underscore number, r dot, you know, last name, r dot first name, C dot customer number. So we have here, and we want to fetch C dot customer name. Okay, so this is what we want to fetch. And what we want to do here is we want to sort as well. So I'll provide the sort order. So I'll say order by first r dot rep underscore number, and then C dot customer underscore number. Okay, so this is the query we want to write. And you can see in my earlier videos how to do joins on multiple tables. Okay, that is not the focus here. So I will run this query here. So it fetches the data for me, and I want to save it as a view. Okay, so this will be my third view as such. So I'll say here, create or replace view rep underscore cust, and I want to give a different name. So I'll say r number for the rep, r last for the last name of the rep, r first for the first name of the rep, C number for the customer number, and C name for the customer name. As simple as that. So this will create a view called a repcust, and it will give different names to the field other than what you have in the base tables. Okay, so a view is created. So if you go here, you should see three views. Okay, let me refresh this one. Okay, so you have three different views here. Okay, there's a third view we created. And so you can use this view similarly like other views. So let's say you want to select star from the rep underscore cast. Okay, so you can do that, control enter, and to the user of the view it will simply appear as a table, but basically it's a derived table based on the two base tables. One is the customer and other one is the rep, that you have to keep in mind. Okay, so moving on, you can create the view based on aggregation as well. So for example, let's say we want to create a view name credit underscore cost that consists of uh, each credit limit, a number of customer having that credit limit. Okay, sort the credit limit in ascending order. Okay, so basically what we need to do here is first write the query. Okay, so I will say select from, we just are going to use one table called customer because that has all the data here that we're looking for. Okay, we want the credit limit, that's all we want, and the number of customer having those credit limits. Okay. So from customer, we have to use, let's say, I would say here, I want to select customer credit limit, and I want to count how many customers are there with this credit limit. Okay, as, let's say, it's always good to give a name. So I say number of customer. Okay, and then we have to use the group by class. Group by, we're gonna say credit limit, and we have to order by credit underscore limit. Okay, so this is the simple query we have to use to create the view. So it gives me credit limit and number of customers having that credit limit, and we want to store it as a view. Okay, so what we can do here is we can say create or replace, let's say view call cred underscore cost, and that's it. So we don't want to give our okay, so the name is the same. Okay, so we don't need to worry about the names. As, okay, control enter, and it'll create a view. Okay, and then you can use this view. So very much like other views, to the user it will simply appear as a table. Okay, so select star from create underscore cost. Okay, so to the user it's simply appearing as a table. Okay, so that's something you have to keep in mind. You can just select one particular field here. For example, you can say I want to just say uh, credit underscore limit, just an example. Okay, so you can do that as well. It will just produce that particular table, so the user it simply appears as a table. Okay, so let's move on. Okay, now so far we have created the view and used it to read the data. We haven't performed any kind of updation, insertion and deletion. So let's do that. So for example, if the view is based on one base table, let's say the first view that we created was based on item table, and if the view consists of the primary key of the base table, which is the item number, then you can update the data in the base table using the view. Okay, provided the field that you're updating uh, uh, that you do not have in the view is not set to not null. Okay, and I will explain what that means. So let's say you want to update view toys and set its description to rocking cat, where the item is fd11. Okay, let's see first what that means. Select, I will say star from toys, that's our view. Okay, and I will also say select star from item, so we can see what's going on. So in the toys we do not have fd11. We do have fd11, and this is what we want to change. But as I said, view is simply a derived table. This is just a query, it's a named query, right? But behind the scene the update will happen in the base table. Okay, which is here. So base table item f11 is there, and this will change. So let's go ahead and perform the update on the view, because to the user of the view is simply the table, right? So we'll say update toys, set uh, description equals rocking cat. Okay, where let's say item number equals fd11. Okay, now um, to the user they are simply updating the toys view, but as we know views, they are simply the derived table, they are not the permanent table. So behind the scene the update will happen in the item table, not the toys, because toys is not the real table here. Okay, that's something you have to keep in mind. So let's go ahead and see what it does here. Okay, so I will control enter. Description description I P T invalid. So did I misspell again? Description. What was the? Let's see here. Not this one. This one. So DESCRIPTION. Okay, looks right to me. Update toys. Rocking cat. DES. Spell it. Okay, sorry for that. So now control enter and one row updated. Now if you run this toy again, you'll see that FD11 is set to rocking cat. If you go to the items table or item table, you'll see FD11 set to rocking cat here as well. So basically you're making changes to the base table. Okay, that's something you have to keep in mind. And this updation is allowed here because we are using item number in our toys. Okay, and there is one-to-one correspondence between the rows of toys view and item table. That's how we were able to update the data in the items table. So inserting a new record using a view, let's see that. Let's say I want to insert into toys values. Let's say I want to insert a new value. Let's say FD98. Okay, FD98. Okay, and I want to set the description to Oracle XYZ. Let's say on hand quantity is 10 and price is 9.20. Okay, now basically you're trying to insert the value um, into the items table using the toys. But if you know toys, the way it is defined, it only has those items that has category set as toy. Okay, but here we are not supplying toy as a category. So I will go ahead and do this one. Say missing comma, I'm missing single quote here. So one row inserted. Now where is this row inserted? Can you see this row when you run the toys? Let's see. Toys here. See, I don't see FD98. Why? Because this view simply is based on the category toy. Okay, and when we inserted the record, we don't have that field category in our view. But does that mean it did not do the update or did not do the insertion in the our base table? Let's check. So if you go to the items table, you see that FD98 is added, but the category is null. And since it is null, we were not able to see that in our, uh, view. Okay, because view is based on just toy category. Okay, that's something you have to keep in mind. Okay, so usually, I can just copy this one here. Okay, and then I will copy this one here just to sort of keep up with my script here. Okay, so we can roll back those changes here. We don't want to do anything there. Now if you remember, let's see, if you describe item table. Okay, item table, it says that category field nulls are allowed, because if it is not, it's going to say not null. Okay, and that's the reason we were able to insert the values. Okay, if this category field is set to not null, then this will not work here. So I want to demonstrate that here. Let's alter this item table and set category to not null. Okay, and see whether we are able to run the above insertion. Alter table item, modify category. So I'm gonna say add a constraint uh, cat not null, not null. So that's a, so we are modifying the category field in the item table and adding a constraint called cat not null. That's the name of the constraint, and not null is the constraint that we want to add. Okay, and I will hit enter. Okay, so this is and altered. So let's describe the item table again, and you can see category is not null. So if you try to do this insertion, so we already rolled back here, right? So let me try to run the item table, and I should not see fd98 because we rolled back changes. Okay, so we don't have fd98. Okay, that was a 16th row. So since I added this constraint, okay, can I go ahead and insert this record now? Okay, so rollback does all the, it rolls back all the changes. Okay, so this row is not there right now because we have rolled back. So I can rerun this one. Okay, so if I rerun this one right now, is it will say that, you know, cannot insert null into item dot category field. Okay, so it's something you have to keep in mind. If the category is set to not null, which is not part of your view, then you will not be able to update the base table. Okay, so that's something you have to keep in mind. So I will go ahead and alter back my tables. So I will say alter table item. I will say modify category. I will say null allowed. Okay, okay, and if you describe the item table now again, so we have taken out the not null constraint here. So that's something you want to keep in mind. So we already tried this one, insertion, and okay, so these things are already done. So this comment should go here. This is where we tried. Okay, now since you have set it to null, and then, you know, can you insert this one? Yeah, so probably if you run this one, yeah, one row inserted because we have allowed the null in the category. Something you have to keep in mind. Okay, now so far we have seen that we can update data in the base table. We can insert new record in the base table. There are some constraints, but please keep one thing in mind. We are able to do that because our view is based on a single table, and view also consists of the primary key of the base table. So there is one-to-one correspondence between the record in the view and the records in the item table. Okay, that's you have to keep in mind. Otherwise, there are other restrictions as you will see going forward here. So let's say you want to delete the record here. Okay, so I'm already seeing that this query not gonna work because you know, fd11 is null. Okay, so for example, let's see here. What I want to do here is I want to first select star from toys and see what I have here. Okay, so I don't have fd98, right? So let's say select star from item. Okay, and do we have fd98? Yes, 16. Okay, so let's say I want to delete this one using my view called toys. Okay, so I will say delete from toys where item number equals fd98, and this will not work because because as you saw here when we ran the toys here, there is no item number fd98, so you cannot use the view to delete something which is not retrieved by the the view. Okay, so if you go to the items table here, command enter, you should still see FD98 sitting there. So you can only delete the data that appears in your view. Okay, if something not appearing in your view, you cannot delete that thing. It's something you have to keep in mind. Okay, so to make the about delete statement work, we need to update the table and set the category to toy. Okay, so I can do that here quickly. So let's say I want to say update item, and I will set category to toy. Okay, where item underscore num equals fd98. Okay, so once we did this update, right now this category is null here, right? You see that. Okay, after this update, let's do the update here, and let's fetch the data from the items table. You see that, now the category is set to toy, so this will be fetched by our toy view. Okay, so that data is fetched now because the category is set to toy, and that our view is based on uh, the toy category, right? So when you created the toys here, we said that the category equals toy, and that's the reason we are able to see that now. Okay, so now about delete statement will work. For example, I want to delete this thing, and you'll see that this will work now. Okay, so one row deleted. So that means if I try to see the toys view data, not there, item table 16th is gone. So something you have to keep in mind. Again, why we were able to delete the data from the base table, because there is one-to-one correspondence between the item number in the item table and the item number in toys table. Okay, so the like basically both the view and the table have the same primary key. Okay, if that is the case, then you can do the insertion, updation, and deletion. Otherwise you cannot. Okay, okay, so that is the one thing. Now let's try to delete something, some other data. Okay, for example, we have this one here. Let's say do we have cd33, right? Let's say I want to delete this thing. Okay, so make sure you go through my earlier videos, right? If you see that there exists one-to-many relationship between item and order line. Okay, if you expand this one, item number is appearing as a foreign key here, item number. The reason we were able to delete fd98, because fd98 did not had any child records. Okay, it did not had any records in the order line table. But what if there is a data in the order line, which is sort of acting as a foreign key to the item number here? For example, what I mean by that is, um, let's see here. So I will say select star from item and select star from, let's say, order underscore line. Okay, let's see, let's say cd33. Okay, that is there in the items table, right? So if you rerun the item table, you'll see that we have cd33, and let's do the order line, and we see that the item number cd33 is there, so it is being referred. So if you try to delete that using view, this will not work because it will violate the referential integrity. Okay, so delete from toys where item underscore number equals, let's say, cd33. Okay, so obviously this will not work because child record found, there is a record for item number cd33 in our child table called order line. So order line becomes a child table, and item is a parent table because there is one-to-many relationship between item and order line. So if you have a child record, then obviously you cannot delete data using views, or even you cannot delete data from the item table itself. So for example, instead of the view, if you try to use the base table called item, this will not work as well, because again we are violating the referential integrity here. Okay, so this will not work. Again, delete from the item is saying that child record found, so something you have to keep in mind. Okay, so let's say so far we have dealt with sort of insertion, deletion, and updation using a view that is based on one base table. Okay, and we have used the primary key of the base table sort of as a primary key in a view, because there was one-to-one correspondence between the records. Okay, but what if the view is based on a join? Because we have created another view called what was the name of that view here? Let's see here, uh, create underscore cost, that is based on the join. Okay, so let's say uh, what we want to do here is we want to let's say update the customer number, a customer name. So the customer name of customer number 126. Okay, so let's see that so for example, let's see what we have here. So select star from customer. Okay, select star from, we have created not the create cost but the rep cost, sorry for that, rep underscore cost. Okay, so this is what we have, and let's say I want to update the customer number 126, a toy scalar to toys oracle. Let's say I want to change the name of this one. Okay, and as you see here, this customer table has the same data 126 toy color, and we want to change the name here using the view. Now uh, so basically, I said this following will work, because why this will work, like if I want to update the statement, let's say I want to say here update rep underscore cost. So remember, I'm updating the base table using the view here. I want to set C name, because that's what we have indicated in our view, equals toys oracle, that's the name I want to change, where C num equals 126. Okay, and that has to be in single quotes because it is defined as a string in our data type. So again, I will run this one, this customer number 126 color, and let's see, I want to change this one. Okay, let's see whether this will work. It says one row updated, so if I fetch the data again, rep customer is changed to toys oracle. What about in the customer table? Yeah, it changed in the base table as well. Remember why this was able to work, because we are using what we call preserved key table, which means that basically there is one-to-one correspondence between the rows of the customer table and my rep underscore cust view. Okay, because we are using customer number as a primary key in our customer table and cnum as a primary key in our uh, view. We don't define the primary key in the view, but basically there is clearly one-to-one correspondence between the rows of the customer table and the that rep underscore cust view here. Okay, so let me see, I just wanted to see whether I can use describe rep underscore cust here. Okay, so everything is not null, so if you're updating it, you have to update, provide all the data, okay, to the base table. Okay, so So that is the one thing you have to keep in mind. And as you know, this rep underscore cost is based on the join of two tables. One include customer table, the other table is the many, the one side of the table, the parent table, which is the rep. So there is one to many relationship between rep and customer. One rep can have many customers, and each customer will be assigned to one and only one rep. So there is one to many relationship. We can update the child table here because there was one-to-one correspondence between the, you know, customer number, between the rows of the customer table and the rep underscore cust view. So let me run this one again. Now let's see the other side of the story here. Let's say I want to change the, first name of the rep number 15. Okay, and I want to compose, I want to call it Oracle. Okay, so let's say, can I do that? Now you will not be able to do that because, this is not the key preserved table. Which, what do you mean by that? Well, not a one row here is not corresponding to the row in the rep table, right? So what do I mean by that? So if you select, let's say, select star from, let's say, rep. Okay, so in the rep table you will only see one record for rep number 15, but here you're seeing four. Okay, and that's why there is no one-to-one correspondence. But 126 here, customer name, you there was only one record in the view, and so was the case in the base table called customer. Okay, so there is one-to-one correspondence there, but there is no one-to-one correspondence here. So this is not a key preserved table. Okay, which means if it is not a key preserved table, I cannot update the base table rep here because there is no one-to-one correspondence, or there is no similar primary key. Rep number cannot be used as a primary key here, but it is a primary key in our rep table. But C number here could be used as a primary key because it is uniquely identifying each record, and that's the reason we have one-to-one correspondence here. So that's something I wanted to demonstrate here. This will this already worked, right? So uh, so we are updating the customer number, right? So but we wanted to update here, let's say I wanted to um, update the rep table, right? So let's say, okay, here I want to write the query here, update rep underscore cust set r first equals to Oracle. That's my favorite name. So where r num equals 15. Okay, I guess r num 15 should be in single quotes because we define that as a character here. Let's see, let's try to run this one. So it says that cannot modify a column which maps to a non-key preserved table. So rep table is a non-key preserved table. Why? Because there is no one-to-one correspondence again between the rows in my views and the rows in my rep table. But we were able to update the customer name here because there is one-to-one correspondence. A customer table is a key preserved table, and there is one-to-one correspondence between the rows of the view, rep, cust, and the customer table. That's something to keep in mind. You can only update a view, you can only update the base table using a view if you are targeting fields in the key preserved table. Okay, so in other words, if the view consists of the join that's joining multiple base table, you can always update the child table. Okay, and while doing so, you have to make sure that the fields which are not mentioned in my views are not set to not null, if which I already demonstrated up there when we wanted to update category. Okay, so this is how you would do simple you would create simple views and use them. If you do not need the views anymore, the simplest way to drop is like you drop the table, you say drop view, let's say device, okay, and that view will be gone. So if you refresh here, let's say refresh, you see that view is gone, that view is not there anymore. So if you do not need the views, you can simply delete them. So with this I will end my video here. Thank you very much for watching.